Hello space enthusiasts, and welcome back to our channel. Today, we're taking a grand tour to the undisputed king of our solar system, the colossal and captivating planet Jupiter. This gas giant is so massive that all the other planets in our solar system could fit inside it. So, buckle up as we dive deep into the mysteries of this swirling, stormy world. Jupiter is the fifth planet from the Sun and the largest in our solar system. It's a gas giant, meaning it doesn't have a solid surface like Earth. Instead, it's mostly composed of hydrogen and helium, the same elements that make up the Sun. When you look at Jupiter through a telescope, you're not seeing a surface, but the tops of its vibrant clouds. These clouds form colorful bands and zones that race around the planet at incredible speeds. The lighter colored bands are called zones, and the darker ones are belts. These are created by strong east-west winds flowing in opposite directions at different latitudes. And of course, we can't talk about Jupiter without mentioning its most famous feature, the Great Red Spot. This isn't just a spot, it's a gigantic, centuries-old storm, wider than our entire planet Earth. Imagine a hurricane that has been raging for at least 300 years. Winds inside this storm can reach speeds of over 400 miles per hour. While it has been shrinking over the past few decades, the Great Red Spot remains one of the most powerful and enduring weather phenomena in the solar system. It's a constant reminder of the sheer power and dynamic nature of Jupiter's atmosphere. But Jupiter's weather isn't just about the Great Red Spot. The entire planet is a chaotic and beautiful mess of storms, vortices, and lightning. In fact, lightning on Jupiter is incredibly common and powerful, sometimes hundreds of times more energetic than an average lightning bolt on Earth. These flashes of light, however, are concentrated near the poles, unlike on Earth where they're more common near the equator. Scientists believe this is due to the way heat is transported from the planet's deep interior. Speaking of its interior, what lies beneath those thick clouds? Well, it gets pretty extreme. As you descend through the atmosphere, the pressure and temperature increase dramatically. The hydrogen gas eventually gets so compressed that it transforms into a liquid. Deeper still, the pressure becomes so immense that the liquid hydrogen behaves like a metal. This layer of metallic hydrogen is what generates Jupiter's incredibly powerful magnetic field. This magnetic field is nearly 20,000 times stronger than Earth's and creates a vast magnetosphere that stretches millions of miles into space, even reaching past the orbit of Saturn. This magnetosphere traps charged particles, creating intense radiation belts that would be extremely hazardous for any unprotected spacecraft or future human explorers. Now, let's talk about Jupiter's family. This giant planet isn't alone. It's accompanied by a retinue of at least 95 known moons, each a fascinating world in its own right. The four largest and most famous are the Galilean moons. Discovered by Galileo Galilei in 1610, their discovery was a pivotal moment in astronomy, as it showed that not everything in the universe revolved around Earth. First up is Io, the most volcanically active body in the entire solar system. Its surface is constantly being resurfaced by hundreds of volcanoes spewing sulfur and sulfur dioxide, giving it a mottled pizza-like appearance of yellow, red, orange, and black. This intense volcanic activity is caused by the immense gravitational pull of Jupiter and the other Galilean moons, which constantly squeezes and heats Io's interior. Next is Europa, a world that has captured the imagination of scientists and sci-fi fans alike. Europa is covered by a smooth, icy crust, crisscrossed with dark streaks and cracks. What's so exciting about Europa is what might lie beneath that ice. A vast global ocean of liquid salt water. The same tidal forces that heat Io are at play on Europa, likely keeping this subsurface ocean from freezing solid. Where there's liquid water, there's the potential for life. This makes Europa one of the most compelling places in our solar system to search for extraterrestrial life. Future missions are being planned to explore this icy moon and potentially even drill through the ice to sample the ocean below. Then we have Ganymede, the largest moon in the entire solar system. It's bigger than the planet Mercury. Ganymede is a unique world, the only moon known to have its own magnetic field. Its surface is a mix of old, dark, heavily cratered regions and younger, lighter grooved terrain, suggesting a complex geological history. Like Europa, Ganymede is also believed to have a subsurface ocean, though it's thought to be sandwiched between layers of ice. Finally, there's Callisto, the outermost of the Galilean moons. Its surface is the most heavily cratered of any object in the solar system, meaning it's ancient and has been geologically quiet for billions of years. It's like a frozen, preserved record of the early solar system. Callisto might also hide a subsurface ocean, but it would be much deeper and less likely to interact with the surface compared to Europa's, beyond the Galilean moons. Jupiter hosts dozens of smaller, irregular moons, many of which are likely captured asteroids. These moons have eccentric tilted orbits and add to the complexity and richness of the Jovian system. Jupiter also has a faint ring system, not nearly as spectacular as Saturn's, but present nonetheless. Discovered by the Voyager 1 spacecraft in 1979. These rings are composed mainly of dust kicked up from its inner moons by micrometeoroid impacts. Jupiter's immense gravity plays a crucial role in the architecture of our solar system. It acts as a sort of cosmic gatekeeper or big brother, its gravity, deflecting comets and asteroids that might otherwise head towards the inner solar system, potentially protecting Earth from frequent catastrophic impacts. However, it can also fling objects out of the solar system or send them on new, potentially hazardous trajectories. Its influence is undeniable. Humanity has sent several robotic explorers to study Jupiter up close. The Pioneer and Voyager missions gave us our first stunning close-up views in the 1970s. The Galileo spacecraft was the first to orbit Jupiter, studying the planet and its moons in detail for nearly 8 years. More recently, the Juno mission has been orbiting Jupiter since 2016, flying closer to the planet's cloud tops than any spacecraft before it. Juno is revolutionizing our understanding of Jupiter's atmosphere, interior structure, and powerful magnetic field, providing breathtaking images and invaluable data. So, what have we learned? Jupiter is more than just a big planet. It's a complex, dynamic system in itself. A world of violent storms, a powerful magnetic engine, and a miniature solar system of diverse and captivating moons. From the volcanic inferno of Io to the potentially life-bearing ocean of Europa, the Jovian system holds countless secrets waiting to be discovered. It's a reminder of the scale, power, and beauty of our cosmic neighborhood. The King of Planets continues to challenge our understanding and inspire us to keep exploring. Thank you so much for joining me on this journey to the magnificent planet Jupiter. What fascinates you most about this gas giant? Let me know in the comments below. And if you enjoyed this video, don't forget to hit that like button, subscribe to the channel, and ring the bell so you won't miss our next cosmic adventure. Until next time, keep looking up.